Team, it's Mr. Z. If you haven't watched the first part of this video of lesson 4, I advise you to go back before you continue. Let's go and take a look at the conversion process between radicals and rational exponents. Alright, so looking at this chart, we're going to kind of focus in over here on the left. And the idea is that radical form to the power and exponential form. So when you're looking at it, the radical form, when there's no number listed in the index, you're going to assume that it's going to be a 2 because it's a square root. When I write it as a rational, what it's going to be is it's going to be x is going to be 1 to the blank power. It's going to be x to the first to the second power. When I look at this next one, the cube root of x, what is this going to be? Well, the x power is going to be 1, and it's going to be to the third, because that's the index. Now, when I continue again, this is going to be the fourth root of x squared. And notice there's just one of them. So what this is going to convert into is it's going to convert into x squared to the 1/4 power. Now I have to multiply. Whenever an exponent is raised to an exponent, I multiply it out, and I'm going to get x's to the 2/4 power. Now going backwards, if I wanted to go the other way, if I gave it to you as a rational exponent, I would know the denominator would tell me what is the root of the radical, and then it's going to be to the third power, and then just x. What is this going to be? Well, this is going to just be the fourth root of x to the third. Both of those are equivalent. I can do it again. I can represent it as the fifth index with x to the square power. And then I can convert it to just say, well, it's the fifth root of x squared. Going the other way, I see no exponent, so it's going to be the fifth root of x to the first power. I know that this is just going to be x to the 1/5. I hope these examples have helped you between the conversion process. The idea is that you should be able to switch between radical form and exponential form. So in number 9, it says rewrite each expression in radical form and as an expression with a rational exponent. The cube root of x is going to be, well, the cube root of x, and then it is also x to the 1/3 power. The cube root of x squared is going to be x to the 2/3 power. Notice in both of these examples, the power was the numerator, and the index was the denominator of the rational function. I'm going to repeat this again. I have to rewrite it as an expression with a rational exponent. So this guy is going to be 3 to the 1/7 because there's only one 3. X to the 4/7, and then y to the 9/7. I do want to point out that when you have an improper fractions must be simplified. So I'm going to keep on going. I have to go the other way. 5 to the first power to the 7th radical times the 7th radical x squared times the 7th radical of y to the 4th. I can rewrite this as one giant radical 5x squared y to the 4th. Okay, now let's actually go to simplifying these. So the idea I kind of alluded to before is that improper fractions must be simplified. So if I convert 11, it is going to be x squared 2 over 2. That is going to just be x to the first, leaving me with just an x. For 12, I'm going to take the square root of 4, and I'm going to have to take the square root of x to the 6th power. The square root of 4 is 2, and I'm going to represent x to the 6 over 2. This is going to leave me with 2x to the 3rd. Let's do another one. I rewrite it as a rational expression. X to the 8th power over 4. Well, 8 divided by 4 is just going to be 2. Continuing with 14, I'm going to go ahead and take the cube root of each piece. So I'm going to examine the cube root of negative 8 times the cube root of x to the 4th times the cube root of y to the 3rd. So the cube root of negative 8 is just negative 2, because negative 2 times negative 2 times negative 2, aka 3 times, makes negative 8. And then I'm going to multiply it by x to the 4 thirds times y to the 3 thirds. Now, I'm going to have to rewrite the improper fraction as a mixed number. So over on the side, I go back to the days of division. 4 being divided by 3. 3 goes into 4 one time, and then I'm done. I go around the world clockwise, and the equivalent of 4 thirds is 1 and 1/3. So I'm going to go ahead and continue, negative 2x, but instead it's going to be, I'm going to have x to the first, and then I'm going to split it up, x to the 1/3 times y, 3 over 3 is just going to be 1. So now I'm going to organize some of my information based on who is a fractional exponent and who is not. So this is going to lead me to have negative 2x to the first power times y times x to the 1/3 power. So the idea is that after you look at all of the pieces, you try to simplify each piece, and then you reorganize based on who's a rational exponent and who's a regular. Then I'm going to make the final conversion, negative 2xy times, well, the cube root of x to the first power. I could leave that first power off because it's assumed. This would be my answer. So 15, let's repeat. Square root, take the square root of 18, and then I need to take the square root of x to the 10th. Well, the square root of 18, I could rewrite it as the square root of 9 times the square root of 2. And then I can rewrite this as x to the 10th divided by 2. The square root of 9 is going to be 3 times radical 2 times x to the 5th. I'm going to reorganize my information, and I'm going to write it as 3x to the 5th times square root of 2. The reason it's more simple is because less terms are inside of the radical. Okay, let's do 16. The third root. I need to take the third root of 64. I'm going to take the third root of x to the 5th, and I'm going to take the third root of y to the 7th. Well, I know 4 times 4 times 4 is going to be 64, so that part's okay. And then I'm going to rewrite this to be x to the 5/3 times y to the 7/3. To convert it into a mixed number, what I'm going to do is the division that I did up in the purple. First in line, first in the box. I'm going to divide 5 by 3. 3 goes into 5 one time. And then I get 1 2/3. 4, 7 divided by 3. 3 goes into 7 2 times. I'll have 2 1/3. So 4, and I can split this up. It's going to be x to the 1 2/3, and it's going to be y in the 2 1/3. I'm going to regroup this to be 4 times x to the 1st, x to the 2/3 times y squared times y to the 1/3. My final step is to rewrite the rationals into a radical. So I'm going to rewrite it to be 4. There's an x to the 1st and y squared. And then I'm going to rewrite my fractions as x squared inside of the cube root times the cube root of y to the 1st. And then I'm going to simplify it one step further by writing 4xy squared. And then I'm going to write it times 3 root x squared y. So the idea is rewriting them as mixed numbers is going to reveal what goes in front of the radical and what is going to stay behind. So we're going to rewrite some more expressions. And we're going to write our answers in radical form. Number 17. I see 16. And I'm going to go ahead and figure out what is the 4th root of 16. What is the 4th root of x to the 6th? And what is the 4th root of y to the 8th? Well, 2 times 2 times 2 is 16. 4 2's make 16. This is going to be x to the 6/4. And then this guy is going to be y to the 8/4. So rewriting it as a rational is going to start my process up. Now, I got to rewrite it as a mixed number. So I have 2 times x to the 6 over 4 times y to the 8 over 4. Well, this is going to turn into x to the 1 and 1/2. This is just going to turn into y squared. And this is going to stay 2. I'm going to split up my green term. It's going to be 2 times x to the first times x to the 1/2 times y squared. I'm going to reorganize this to be 2x y squared times x to the 1/2. And then I'm going to rewrite that as the square root of x. $18 is very similar. Take the square root of 36, the square root of a to the 4th, square root of b to the 3rd, square root of c to the 10th. Well, I know that the square root of 36 is going to be 6. This is going to be a to the 4 over 2. This is going to be 3 over 2. And then this is going to be 10 over 2. Again, simplifying, it's going to be 6a squared. B is going to be 1 and 1/2 times c to the 5th. 1 and 1/2 is equivalent to b to the 3 over 2. I'm going to split this up further. So this is going to resemble 6a squared. Then it's going to be b to the 1st, c to the 5th, and then b to the 1/2. I'm going to rewrite it again. 6a squared. This is just b, c to the 5th, and it becomes the square root of b to the 1st power. Again, the cube root of 64. I'm going to take the cube root of 64, the cube root of x to the 4th, and the cube root of y to the 6th. The cube root of 64 is going to be 4. This is going to be x to the 4/3, and this is going to be y to the 6/3. This is going to simplify to be 4 to the x 1 and 1/3, y to the 2nd power. I'm going to rewrite it again, but I'm going to organize my whole rationals to the left, keep my fractionals to the right, and then I'm going to convert it back. For x, because to the first I don't have to keep rewriting it, to the cube root of x. Number 20. Take the square root of 24 and the square root of a to the 5th. I know a perfect square that goes into 24 is going to be 4. So it's going to be the square root of 4 times the square root of 6 times a to the 5/2 because it's an index of 2. I know that square root of 4 is going to be 2 radical 6. And then that this, after I divide, it's 2 and 1/2. When I regroup this, I'm going to keep the 2. the a squared. Then I'm going to write the square root of 6 because times, well, this is going to be the square root of a to the first, and then I'm going to combine it. 2a squared times a radical of 6a. I don't need to rewrite the exponent of 1 because that's assumed. All right, I hope this helped, team. This is it for part 2.